everybody. It's Monday, the 27th of April, and this is Nighttime Mathematics Radio. Format of the show is always the same. Tweet your questions to @NightMathRadio on Twitter, and I'll try to answer them right here, live on the air. So, in the strange world where all the classes have stopped, but the homework goes on and on and on, I'll try to help you all out. So, before we get started, let's take a minute or two for people to tweet in any questions they might have. If not, we've got an interesting question I dredged up on Twitter. I'll try to answer it right here. This is Nighttime Mathematics Radio. Welcome back to Nighttime Mathematics Radio. Well, the question that came in earlier is one about negative and fractional exponents, and this is a problem that is tricky to follow sometimes, and the reason is the transition between positive integer exponents and negative and fractional exponents is a bit tricky to catch because you actually change what you mean by an exponent halfway through it. If you're really awake in class, you can catch when that happens. But as I said at the top of the hour, all the classes are gone at the moment. All we have are a couple of YouTube videos, some Zoom meetings, and a whole lot of homework. So it's not surprising people missed that transition. So let's look at how it goes. Now, the actual question that was asked was to find two exponent problems that look like this. First one says, what is 4/3 to the minus 1 power? And the second one says, what is 4/25 to the negative 1/2 power? And this gets tricky, as I say, if you didn't quite catch what happened when we switched from positive integer exponents to general exponents. Because when we first introduce exponents, we say things like this. We say, well, what's 3 cubed? And the answer is, well, what we mean by cubed is this is 3 times itself 3 times. This is repeated multiplication. So this is 27. Or if we say, what's 2 to the 6th? Well, that's literally 2 times itself 6 times. That's 2 times 2 times 2 times 2 times 2 times 2. And we count that up. That's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. And at first this looks exactly like the sort of convenience we did back when we first learned addition and subtraction. When we moved to multiplication, we said, well, what's multiplication? Well, it's just repeated addition. And now we have exponents. They say, okay, this is just repeated multiplication. This is the same trick again. So it all looks very simple. And then we learn from this a couple of cool rules. We learn that, for example, if you have two exponents times each other, that's just the sum of the two exponents, because after all, that's 2 times itself twice, times 2 times itself 3 times. And if you count up all the 2's I've just written down, that's 2 plus 3, so that's 5 repeated. So you get that 2 squared times 2 cubed is just 2 to the 2 plus 3, or 2 to the 5th. And that's just by the definition of repeated multiplication that we just used. And similarly, we could say, well, what's, say, 4 to the 5th divided by 4 cubed? And the answer is that's 4 times itself 5 times, divided by 4 times itself 3 times. We can cancel 4s. That leaves us with 4 squared. And so we end up with these cool rules where we say, okay, first of all, any number to the first power is just equal to itself, because after all, that's repeated multiplication once. That's easy. We say anything to an exponent times the same number to some other exponent is just the sum of the exponents. And then finally we say that if you have something to a power over that same number to a different power, that's just equal to a to the b minus c if b is greater than c. Because after all, that's the only time repeated multiplication makes sense. If b is less than c, then we're going to end up with more things in the denominator, and then we don't have repeated multiplication anymore. So that definition no longer makes sense. And where we move on from here is we look at that, we say, this if is sort of a shame, isn't it? That if is kind of awful. So what if we do something else? And this is a game we play a whole lot in mathematics. What we do is we say, I like these rules so much that I just wish the if wasn't there. So I'm going to change what I mean by an exponent. Instead of saying exponents are repeated multiplication as my definition, which remembers how we started, I'm going to say these rules are my definition, and I'm going to lose the if, because I don't want that if to be there. So I'm going to say exponentiation is a thing that works like this. It's a thing where anything to the first power is itself. Multiplication, you add the exponents, and division, you subtract the exponents. And now the really cool thing is, as long as the exponent is a positive integer, as long as it's 1 or 2 or 3 or 4 or 5 or whatever, this is still a repeated multiplication. It has to be. Because after all, what's a to the second power? Well, it's a to the first power times a to the first power by this rule, which is a times a by the first rule. What's a cubed? It's a squared times a to the first. We already know the first one's a times a. We just proved that. The second one's a again. And you can keep this going as long as you like. So, or if you're a little further along in math, you could use mathematical induction to prove that this is really just repeated multiplication as long as that exponent is an integer. But now we can do new things we couldn't do before. For example, we could say, what's 2 to the 0th power? Before that made no sense. That's what happens when you multiply 2 by itself, not at all. And the answer is, I have no idea, go away. But now it makes sense, because now this must be 2 to the first power divided by 2 to the first power, because after all, we said the division rule works. And that's just 1. In fact, by that same logic, anything that's not 0 to the 0th power must be 1. Same logic, because it must be a over a. So now we know something new. Now we know that, because we're no longer saying this is repeated multiplication, now we're saying it's this thing which obeys these rules, we now can say what something to the 0 power is. It's cooler than that. Let's look at those two problems we were asked to solve earlier on. Sorry for previous night's work showing up on the bottom pad there. Apologies. Let's look at 4/3 to the minus 1 again. Let's say we don't know what this is. But I just said there is something I do know. Whatever 4/3 to the minus 1 is, if I multiply it by 4/3 to the first power, that's got to be, again, these are numbers. Our rules are our rules. So this must be 4/3 to the minus 1 plus 1. which is, after all, 4/3 to the 0, which is 1. So in other words, what is 4/3 to the -1? Well, it's that thing that if I multiply it by 4/3, I get 1. But I can solve that. I can divide both sides by 4/3, just like I would everywhere else in math. So this is 1 divided by 4/3. You know how to divide fractions? You just multiply by the reciprocal. So in other words, 4/3 to the -1 power is just 3/4. Because that's the thing because 3/4 is that thing that if I multiply it by 4/3, I get 1. And in fact, that works for any fraction. If I have any fraction a over b, where a is not 0 and b is not 0, and I take it to the -1 power, I can do exactly what I did up here and see that that's just b over a. So in other words, something to the -1 is just 1 over that number. 4/3 to the -1 is 3/4. 6/8, well, that's just 3/4. Say 6/7 to the -1 is 7/6. 8 to the -1 is 1/8, because 8 is 8 over 1, and so on. How about the fractions? Remember, we had a -1/2. Let's first look at +1/2. What is 4/25 to the 1/2 power? And the answer is, right now, officially, I don't know. I mean, I do know because I've taken this class before, but let's pretend we don't know. Well, I don't know what it is, but I know what happens if I multiply another one of them in. Because by our rules of exponents, if I multiply it by itself, I have to get 4/25 to the first power. Or just 4/25, because 1/2 plus 1/2 is 1. So what is this thing? It's something that if I multiply it by itself, I get 4/25. We have a name for that already. That's a square root. That thing, when you multiply it by itself, you get this thing. That's just the square root. So 4/25 to the 1/2 power is just the square root of 4/25. Or 2/5. Better yet, you can combine these things. What's 4/25 to the -1/2? Well, it's that thing that if I multiply it by itself, I get 4/25 to the -1 plus 1/2 plus 1 -1/2, which is 4/25 to the -1. But I know what that thing is. We just worked it out up here. A fraction to the -1 is just the reciprocal, 25/4. So what is this thing? This thing is that thing, if I multiply it by itself, I get the reciprocal. So it's the square root of the reciprocal. It's the square. So 4/25 to the -1 to the -1/2 is just the square root of this. It's the square root of 25/4. Or 5 halves. So you can combine these things. A fraction means you take that root. And you can see by exactly the same logic that something to the 1/3, if you multiply it by itself 3 times, will give you the thing inside. So something to the 1/3 power is just the cube root. Something to the 1/5 power is just the 5th root, and so on. And what if there's a -1? Well, that just combines with whatever fractional exponent you have. It's just the reciprocal of what you'd get anyway. And that works for any exponent, not just fractions, right? I mean, if I have 2 to the -3, that must be 1/2 cubed, or 1/8. A negative exponent just means take the reciprocal, as we proved up there. A fractional exponent means take a root, as we did there. Well, what about fractions that don't have 1 in the numerator? What about, say, 2 to the 3/2? What do I do about that? Well, that's a thing that if I multiply it by itself, must give me 2 cubed, because 3/2 plus 3/2 is 3. So this thing is just the square root of 2 cubed, or the square root of 8. And so on. So hopefully it helps. You can always work out what fractional exponents mean, what negative exponents mean, by just remembering how they're defined. And the answer is, going back one page again, They're defined in terms of these rules. These rules must be true, because that's how exponents are actually defined now. It turns out that still means repeated multiplication, but that's now a consequence of these rules rather than being the definition. Exponents are that thing that, if you take something to the first power as itself, if you multiply the same number to two different exponents, you add the exponents, and if you divide the same number to two different exponents, you subtract the exponents. And that's literally how exponents are now defined. And from that you can get everything. This is Nighttime Mathematics Radio. Let's take a short break to see if anybody else wants to tweet in any answers, or any questions rather. So if you tweet a question at Night Math Radio, I'll try to answer it after the break. Otherwise, we'll just end the show. This is Nighttime Mathematics Radio. Stay tuned. Welcome back, everybody. This is Nighttime Mathematics Radio. Well, it's looking like that's the end of the show for tonight. There's no new questions. So again, if you have any questions between now and tomorrow night's show, feel free to tweet them to @NightMathRadio. I'll try to answer them live on the air. This has been Nighttime Mathematics Radio. So in this weird world where the homework goes on and on and on, but the classes all seem to have turned into Zoom meetings or YouTube channels or Lord knows what else, keep tuning in. Pacific Time, 9 p.m. weeknights to Nighttime Mathematics Radio. Good night, everybody.